let's just test phase, and then we get started. Okay, let's test the microphone. Want to make sure microphone is functioning very well. Okay, let's just come here, make sure. Yes, everything's perfect. So let me just share the link with my brother and sister so we can get started. Okay, share the link with him. Okay, just a minute. I'm gonna share the link with everybody, with my brother and sister. I call them my brother and sister, so I can get started with the class with them. Okay. Okay, should I share this? No. A minute. Okay. Okay, I'm just sending the link to my brother and sister so I can get started with the class very soon. Okay. 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 So if you have already okay, let me just show the links here just to make sure if everybody's here. If you're ready, just simply click that link and then it's gonna take you to our live and then we can start with the class. But if you're in already, just leave a comment that tell me, hey, I'm on already, and then we can get started. That's all. I'm just testing here, right? I want to test my microphone. I hope everybody can hear me. If you don't, you let me know. Okay, just make sure here. Okay, everything's perfect. Okay. Okay, so if you're here on live, just let me know, hey, I'm here already. Oh, okay. Portia Otter say, hello, Mtwana. I'm right here. All right. I see you right there, Portia. Portia, what is your other name? Because as far as much as I know all my beautiful students, my all beautiful family. But what is your other name that I will always chat with? Because that name is like Elum Twan, I'm here. Oh, sim Elilum Twas. But sim look, this is not for you. So it's gonna get you confused. But you can learn if you want. But hey, I don't want you to get confused. This is for sim this is for your next year. Okay, this is for the next year for you. Okay, this is for your next year, sim But Portia Ara, what is the name that you always chat with me? Like when you chat with me inbox, because no problem. I'll see you there. I'll see everybody. Okay, so if you live right here, tell him, I'm here. No, I'm out. Oh, come on, you can leave. Come on, sim we're not chasing you out. You can be here if you want. Okay, Tato, I see Tato's here. Tato, if you live, if you're already here in the live, just say, hey, I'm here. I'm live. I see there's 4 people watching. We're gonna get started right now. Oh, Spongila, I see you right there. Okay, Spongila, she's here. Okay, we're gonna start within 2 minutes time, right? We want to make sure everybody's here. I'm also here from Dabin, Kate. Mamela, I see you right there, my brother. I see you right there. But hey, all my QMI beautiful brothers and sisters, this is not for QMI. If you do DSC 1620, DSC 1520, MAT 1501, and okay, I'm gonna write down all the modules which it has to do with this, because I don't want other people get confused. Okay, so if you do these modules here, and then it's fine. Just be here. Stay here. If you do these modules, which I'm gonna write here down, make sure you're here. Oh my God. So if you do these modules, and then stay here, I'm gonna write all the modules, which is supposed to be here. Okay, I'm gonna write down all the modules because I don't want people to get confused, okay? Yeah, I see you, my brother there from KZ10. I see you right there from KZ10 all the way. Zandiso is here. Zandiso, I see you right there. Zandiso today she decided to come here. Hey, oh, Lina Martley, she's here also. My brother Innocent Memela, she's here also. Monkile, everybody's here. See, Elile, I think you're gonna get confused. Unless if you wanna learn, no problem, you can be here. But if you do QMI, please don't stay here. You're gonna get confused. Unless if you just wanna learn for fun. Okay, so I'm gonna list all the modules. If you do these modules, then stay here. Okay, if you do those modules which I've written under there, then stay here in our class. But if you don't do none of those modules, please, I don't want you to get confused and start to hate math. You say, you know what, I don't want to do math no more because of Mtwana. It's Mtwana who caused that. You know, I went there the first day, and then I got confused because he started to teach hard math, but it's not hard at all. Okay, now let's start with the class. So if you do those modules, stay here, okay? If you do those modules, please stay there. Kamogelo, I see you right there, Kamogelo. Let's get started. So without further ado, my name is Mtwana. Let's get started. Let's get to the business, okay? So today, we're going to learn differentiation. So we have a rules of differentiation. Let me take you to the rules of differentiation so you get familiar yourself with the rules of differentiation, right? Let's start with the first rules. Let's start with the first rule. So in the differentiation, we have a couple of rules. Let's start with the product rules. Let's start with the power rule phase. Power rule. Power rule of differentiation. Power rule. So how the power rule works? The power rule is like, let's say somebody give you y equal to x power n. So x power n, you see there's a power here. For example, somebody give you y equal to x power 3. So we have a power letter with a power. So when you differentiate this, look, what do you differentiate on the left? On the left, you differentiate y. So when you differentiate y, it's going to become dy. dy is like to give it respect. Okay? So this is going to become dy. But on the right, what you're going to do, first and foremost, you have to know which number before x. If there's no number, then write 1. Means the number before x is 1. So to differentiate, what you do, take this power multiplied by any number at the back. So 3 times 1, we're going to get 3. Write your x the way how it is. We write our x. And then take the power minus 1. 3 minus 1 equal to 2. So then finally, remember on the right-hand side, you differentiate x. So since you differentiate x, then you must say this must be dx here because it's x. So here is x's and we differentiated x. So we're going to write what? Dx, but you have to write at the bottom. I'm going to do 4 more example of similar one. You're going to understand. This is a first example. So you might be like, what is it doing? I don't understand. What is it doing? No problem. Don't worry about it. I understand how you feel. Y equal to x power n. So what you do when you differentiate, this is y. When you differentiate, it's going to become dy. These are rules, okay? And then this n, you bring it to the back here. So you write your n, write your x the way how it is. So you bring here to the front or to the back, however you can call it. Write your x, and then take this power minus 1. N minus 1 is going to become n minus 1. So these on the right-hand side, these are x's. So since you differentiated x's, you must write underneath over dx. And you have already differentiated. Let me show you more example. I'm going to do like 7 or 6 more example until you understand. Never mind. It's just a first example, right? So don't, like, what is it doing now? I'm getting confused. You're going to understand soon, okay? Somebody give you y equal to 3 negative x power 8. So when you differentiate, these are y's. So you're going to say this is going to become dy and then write equal. Take your 8 multiplied by negative 3. 8 multiplied by negative 3 equal to negative 24. And then write your x the way how it is. Take your power minus 1. 8 minus 1 equal to 7. So this side here we differentiated x. So since you differentiated x, then write underneath over dx. And you have already done differentiated. I'm going to do more example. So these are power rule. Okay, let's do more example. The more example we do, the more you get to understand, okay? So do not have that feel like, oh, no, it's very easy. Somebody give, let's say, y equal to, let's say, 3 over 7 x power 4. So we're going to do the same game. Here, this is y is going to become dy equal, multiply 4 times 3 equal to 12. Write your 12 over, write your 7 the way how it is. Write your x in east position. Take your 4 minus 1. 4 minus 1 equal to 3. And you have done, do the power rule. Okay, we have already done differentiating. But this right-hand side is x's. So these are x's. They must write here over dx because it's x's. You see what I'm saying? We're done already differentiating. I'm going to do 2 more examples, okay? And if you want me to repeat, no, let me do more example, and then you're going to ask me your question you want to ask me, okay? The more example do, the more you get to understand, okay? More example. Somebody give you y equal to, let's say, negative 2 over 9 and x power 4. Or power 14. So they say differentiate. So what we're going to do, we're going to say this is y is going to become dy equal multiply. Take the power, multiply by any number behind. So 14 times negative 2 is going to give us negative 28. Write your x in its position and then take this power minus 1. 14 minus 1 is going to be equal to 13. And then over, write your 9. And you have done already differentiating. That's how we differentiate it. Easy like that. Very easy. Way easy. Way easy. Okay, let's take more example. So this is gonna be the last example, and if you don't understand, you just leave a comment. They say, Twana, I don't understand. Repeat, and then I'm gonna repeat. Okay, let's take more example. Somebody give you y equal to let's say 7 over 2, and they say x power 4. So every time I say 4, let me change the number. Let's say 5. So they say differentiate. Then we know how we're gonna differentiate, because I'm gonna say, well, this y is going to become dy equal, and then you're going to write your 5 times 7 equal to 35. So this is going to become 35. So this is going to become 35, and then over your 2, and then write your x in each position. Take this 5 minus 1. 5 minus 1 equal to 4, and you're done already. But remember, this side is x, so it's going to become, you say, over dx, and you're done differentiating. Hey, my beautiful family, listen. More the last example, and then we move. Like I said, we're going to doing it a little quicker, so you get to understand, okay? More example. Somebody give you, let's say y equal to negative 2 over 11, and here x power 7. So they say differentiate. So you do the same game. Play the same game. So what we're going to do, we're going to say, okay, this is going to become dy. When you differentiate, this is going to become dy equal. Take 7 minus negative 2. 7 minus negative. So you take whatever power you have here, you multiply by the number behind. 7 times negative 2 is going to become negative 14. Write your x in the right position where it's at, and then take a 7 minus 1. 7 minus 1 equal to 6, and then you over, write your 11. And remember, these are x. So since these are x, and they say over dx. And you're done already differentiating. And that's how we get. Okay? Anybody have a question or you want me to repeat, you let me know. Or otherwise, we go to the next example. So I'm going to continue, but whenever you want me to stop or you want me to repeat, then you tell me, hey, I'm trying to repeat, please. And then I'm going to do that. Okay, my beautiful familia? You my one and only beautiful familia. Okay? Now let's go to the next example. So next example, somebody give you, let's say, now we're going to make a challenge a little bit, right? Let somebody give you y equal, let's say 3, and then x, let's say minus, let's say x squared minus, before I go here, let me say something here. If somebody give you y equal to x, they say differentiate. So if this is equal to x, remember here there's a power 1. Even though there's no power, but you have to know it's power 1. Even though they're not going to give a power, but you have to know it's power 1 automatically. Just like when you say, for example, let me just give an example. Let's say you say automat. How many automat? It's just one. It's just one automat. I don't have to say every time one automat. I can just say automat. A house. I don't have to say one house, one person, one car. It's like, yo, are you? People gonna be like, yo, what's the problem with you? Why every time you say one house, one person, one car? Just say car. We know it's a car. It's a one car. So if somebody give me, let's say x, we know x is power 1. Even if they don't tell us, we know it's power 1. So what we're going to do, I'm going to introduce this one. Now let's differentiate. Why introduce? Because it's going to help me to bring the number to the back. So when you differentiate y, it's going to become dy. These are rules, right? It's going to become dy equal. Now we're going to take 1 to the back. When 1 comes to the back, you're going to write your 1. And then, so you always take a number power to the back. And then write your x. Take whichever number you have here minus 1. So 1 minus 1 equal to 0. Okay, but remember this side here, we differentiated x, so I'm going to say over dx. But remember, we know in math, right? Whenever you have anything power 0 equal to 1, anything power 0 equal to 1, Everything we do, all of us here, put power 0 equal to 1. Anything power 0 equal to 1. I'm going to prove to you that's true. My statement is true. Now let's put the calculator here. Let's prove our statement. Okay, let me take any number here. For example, let's say 80. Oh, then 33. Any number power 0 equal to 1. You see, I put these trillion. I don't know whichever number is there. Put power 0. You press there in the power. And then when you press in the power, you see I'm pressing the power right there? It's kind of, okay. Take time. Come on. You see I'm pressing the power, and they say power 0. And then it's going to give equal to 1. Yeah. So anything power 0 equal to 1. Anything power 0 equal to 1, right? Anything power 0 equal to 1. Okay? So even if I have, you familiar, power 0 equal to 1. So anything power 0 equal to 1. So for that being said, this stuff here is going to become 1. So it's like you have a 1 times 1. 1 times 1 equal to 1. So when you differentiate x, you get equal to 1. I'm going to repeat again. Let me use the other letter, because every time I use x, y, let's use the other letter. It's always going to challenge ourselves. Okay, my beautiful familiar? Oh, yes. Let's challenge ourselves a little bit, right? Okay. Somebody say, let's use T and S or M. Okay. M and N. H equal to M power, just M. Differentiate. So since there's no power here, and then you introduce 1 as power 1. And then let's differentiate. When you differentiate H, it's going to become DH equal, take 1 behind any number which is power, you bring it to the back. And they say 1. Write your M, whichever power you have here, minus 1. 1 minus 1 equal to 0. Whichever power you have here, always minus 1. So you minus 1, you get equal to 0. And then these are M. So when these are M, is going to become DM. But you write at the bottom DM. But hey, we just say that now anything power 0 equal to 1. So then this is going to become, we have this 1, and then you remember between here there's a multiplication, and this thing is going to become 1. 1 times 1 equal to 1. That's all. Okay, so our answer equal to 1. So what did you learn here? One more example, the last one. I think you understand this part, right? So then we say, whenever you differentiate, let's say y equal to x, you know this is going to become dy, because this is just y, and this is going to become over dx, because these are x's. And when you differentiate x, just write equal to 1. If you just say x, if it does not have any power, okay, just say equal to 1. Just say equal to 1 if it doesn't have any power. Okay? So if somebody give me, for example, let's say y equal to x cubed plus 2x plus 8. They say find dy dx. Find dy over dx. So I'm going to say this is going to become dy, because these are y's, and then equal, okay, let's differentiate. These 3 is going to come to the back. It's going to become 3, and write your x as it is. 3 minus 1 equal to 2, and then we plus. But we know this is just a number, has nothing to do with the differentiation. But when you differentiate x, we know it's going to give us 1. We just explained now. If there's no power here, when you differentiate, it's just going to give you 1. You don't have to waste your time. It's just going to give you 1. And then, if this number has nothing to do with the x, we call it constant. And when you differentiate constant, you get 0. Okay? So remember, these are x's. So you must write over dx. So then you're going to say, finally, my answer is going to become 3x squared plus 2 times 1 equal to 2. And then I don't need to say plus 0, because just a 0. More example. I'm going to do more example. And like I say, right, look, if you got a question, or if you want me to stop, you tell me, hey, I'm trying to stop. But like I say, I'm going to give a lot of example, right? The more example I do, the more you get to understand, right? Than us stuck on one question and do slowly. And then that question is not going to come in exam. That's why you have to do a lot of example and a lot of questions, so you get used to the concept, right? Example. Somebody give you more example. Y equal to, let's say, negative 4 x power 5, let's say plus 7 x plus a plus 3. Now let's go and differentiate. So this is going to become dy equal, now let's take 5 to the back. 5 times negative 4 equal to negative 20. Write your x, whichever power multiplied by the number behind. 5 times negative 4 equal to 20. Write your x the way how it is, okay? And then say whichever power you have here, minus 1. 5 minus 1 equal to 4. And then you put your plus. Now, we don't have a power here, right? So since you don't have a power, this x, when you differentiate, is going to be 1 if it does not have a power. So then you're going to have it just like a 7 times 1. Okay? And then you plus. This has no x. So we assume it's a constant. And when you differentiate constant, it's going to give you 0. And then plus, when you differentiate the 3, is going to give you 0. okay? Because this is going to be constant and constant. It does not have an axis, okay? And you differentiate only axis on the right hand side. On the left hand side is why we get dy. But remember, since these are axes, you must say over dx just to give it respect. So our final answer is going to become dy over dx equal negative 20 x power 4 plus 7 times 1 equals 7, and we're done. These are 0, 0. You don't have to say 0. If it's we did grade 1, we say 4 plus 0 equal to 4. X plus 0 equal to x. So anything plus 0, we don't have to write something else. We just need, that's something we need. We don't need the 0. 0 is like nothing exists. More example. More example. Okay, so far, if you have any question you want me to repeat, please let me know. But let's keep moving. You're going to get used to the concepts, okay? You're going to get used to the concept. You're going to get used to the concept, okay? Oh, yes. Okay. Now, let's challenge ourselves a little because it was like same thing. Okay. Now, we're going to change a little bit the format. For example, somebody give you, let's say y equal to 1 over x power 3. So before I differentiate, first and foremost, I must take it to the top. You make sure this must be to the top. So I'm going to say there's a lot of ways you can do, but for now, I'll say do like that. If it's just 1 over x cubed or 1 over any number at the bottom. So this is going to become, so before I differentiate, I must make sure this must come to the top. So it's going to become y equal, we know how to reciprocate, right? This we know is plus. When it goes to the top, we reciprocate. That process we call it reciprocation. So we're going to write our 1, it's just a 1, and then we take to the top, it's going to become x. You see, it comes here. But since it comes to the top, if this positive is going to become negative. So that process before you differentiate. Because for you to differentiate, make sure you reciprocate to the top. Now, yes, you can differentiate. Now I'm going to say when you differentiate y, it's going to give me dy equal negative 3 times 1 equal to negative 3. Write your x, okay? And then whatever number you have here, you minus 1. Negative 3 minus 1 equal to negative 4. So this is going to become negative 4. But this side are x's, so we say over dx. Okay? Listen. So we're done solving it, but you don't leave your final answer like that, negative power. Nobody want to be left with debt. It's like, you want to live with a negative power? Oh, yeah. No. You don't want to live with a negative power. So, listen. So that you want to say, I'm going to write my negative 3. I'm done differentiating, but I'm not going to leave my final answer as a negative power. So I'm going to reciprocate back to the bottom. Means I'm going to bring it to the bottom here. So it's going to become over. This x power negative 4 is going to come here at the bottom. But remember, it's not going to be negative 4 no more. You're going to change the sign. When it goes to the bottom, it's going to become what? Positive. In that process, you call it reciprocation. Reciprocation. Okay? More examples. And this is going to be a fun answer. More example. I know, like, oh, why this is different now? Like, it's not like the one you did. I know, okay? I'm going to take you there little by little, okay? Little by little. Until you understand clear, okay? More example, speed and accuracy. Then I'll start with one question because then you're not going to learn, okay? Because this is called crash course. Okay, let's go. Because we got a lot of things here to cover. Now, somebody give you, okay? Somebody give you. Let's say what? Okay. Now, we know from the exponential rule, if you have, let's say, x, n over m can be any letter. This, if you want to put as a power, what you do, you write your whatever you have, and then flip this stuff, is going to become n over n. Can you see? This go to the top, this go to the bottom. So this is a way of changing root to the power. For example, somebody give you, let's say, square root of x. 3. So we know this 3 must be two number here like m and n. So I'm going to say this can be 3 over 1. You introduce 1 at the bottom. And this going to become, okay, write your x. And the flip is going to become 1 over 3. And you have already changed from the root to the power. Some of you are very familiar with this, okay? Why am I introduce this? I'm going to show you why I introduce you this. Okay, more example. More example. More example. Oh, let me check face. I think some of my beautiful familiar here have not maybe perhaps get the links. Let me make sure everybody has a link because I don't want to be very unfair here and some people missing the link, and I apologize for it. Just a minute for time. So make sure everybody has a link. Okay, let me see. Okay. Let me make sure everybody has a link here because I don't want to be some people say I'm trying to look. You didn't tell me. I didn't know that was not. I didn't know it was a link or not. So I want to make sure everybody has a link. Okay. Let me see. Everybody has a link. Everybody has a link. Everybody has a link. Everybody has a link. Okay. Let me see. Oh, some people do not have a link here. And apologize. Okay. Okay. Just a minute, right? I want to make sure I reply to everybody. Okay. Sorry about that. I just want to make sure everybody's here, right? So, we don't treat some people unfair. It's not fair if we do that, right? Everybody must be, treated equal. So you guys are going to say, I'm trying to, I'm upset. Why you didn't send me a link? Come here. Okay? I want to make sure everybody has a link. My beautiful family. Okay, cool. I think I sent to everybody now. Let me see. Thinks I have everybody's link. Yeah, everybody has a link. Let me see. My beautiful family, you got a link. They have a link. Let me see. Everybody. Yeah, I believe everybody has a link now. Okay. This one. Okay. Okay. Cool. Now we go. And I'm sorry about that. So we're ready to go. We're ready to rumble. Okay. So now, like I said, right? Why did I introduce you to this? Let me tell you why I did I introduce you to this concept. Because let's say somebody give you this, right? More example. So somebody give you, let's say, square root of, let's say, x. So we know here, why do they call this square root? Because here there's a 2 and here there's a 1. So this may say x and this is 1 over 2. Because what you do, okay, look, they're going to give like that. Okay, so this is not differentiation because you have to be very, very familiar on changing the root to power because there's something very, very important we're going to do very, very soon, differentiation. So you need to know this concept right here. Somebody give you here, change this to power. So if there's no number, because they're not going to give a number. So if there's no number, means here is going to be 2. And they say 2 over 1. Remember that. That's what we call a square root. And then you say x, flip this number, it's going to become 1 over 2. You see what I'm saying? It's going to be 1 over 2. Remember that concept, okay? Let me say it again. So if somebody give you, let's say, square root of x, they give 3 here. So we know this 3 is going to become 3 over 1. And then put that in power, it's going to be x. And flip this number, it's going to become 1 over 3. Remember that. That's very important, okay? Now, let's go to the question. Why did you learn that? Why did you learn that? Huh? Why did you learn that? Let me show you now why did you learn that one, okay? Let's go to the question now. Let's go to the question. And then you're going to see why did I introduce you to this, huh? Why did I introduce you to the root to the power? Hey, listen, my beautiful family. We are about 6 people here watching. Click the like button. Show Mtwana some love, right? If you not click the like button, man, you must be hater, man. Don't be hater, man. Don't be like my beautiful family of yesterday. The one who had a class at 6 p.m. There was like a one hater, man. You didn't even click the like button, yo. Let's go. So somebody give you, for example, somebody say give you a question like let's say differentiate. No, let's say give something like this. Let's say y equal to square root, and they give 3 here x. They say differentiate. So first and foremost, I'm going to have to change this root to the power. So change this root to the power means I'm going to say this may say y equal to x, but here I'm going to introduce 1. And then I'm going to say x 1 over 3. 1 over 3. That's the first step. Okay? So when it's in power like this, it's going to be very easy for me to differentiate because I know here there's no number means there's a 1. So I'm going to say when you differentiate y, it's going to give you dy. And then you're going to take 1 over 3 to the back. It's going to become 1 over 3. Write your x the way how it is. Take 1 over 3 minus 1. Take your calculator, subtract. I know a lot of you are beginner. So what you're going to do, let me show you quick. Because someone said, oh, how did you get there? Let me show you. Take your calculator. Okay? But you should know this is very basic. I don't need the calculator. I don't need no calculator. But I want to show you. Okay? Because I know most of you here, this is a crash course. So some of you don't even know how to subtract. So I'm going to say we have a 1 over 3. So you come here to the fraction. You say fraction. We say 1 over 3 1 over 3, or whichever number which is there, the power, and then you minus 1. Whichever number you must minus 1, and never do other way around, okay? Because you're gonna be in trouble. Math has the rules, and you have to follow the rules. If you wanna do your own rules, means you're not gonna make it, okay? Now, so you say whatever you have a power there minus 1. So if you take this, it's going to be negative 2 over 3. Negative 2 over 3. So we come back here. Negative 2 over 3. Come back to our page. Okay, so negative 2 over 3. So if I take this minus 1, it's going to give me negative 2 over 3. So remember, you differentiated x is on the right-hand side. Since you differentiated x, then write over dx. And you're done already. But hey, look, you're not gonna leave your final answer with a negative power, even though I'm done differentiating it. So I'm gonna say this same as say, I'm gonna write 1 over 3. Let me write here on the top. Okay, let's just go quick because we have to go very, very quick. There's a lot of things I want to explain to you guys. So then I'm gonna say, okay, well, dy dx, dy over dx equal 1 over 3, and then I'll take all this stuff to the bottom, even though I'm done differentiating, but I'm not gonna leave my final answer with a negative exponential. So this is gonna come to the bottom. X negative 2 over 3 is not gonna be negative 2 over 3, it's gonna become positive. That's all you've done. All you do, take to the top, to the bottom, and then write as a positive instead of negative. You change the sign, and that process we call it reciprocation. Okay, now, excuse me. Let's take more example. 3 more example, and then we're gonna get to the assignment, to some very, very crucial, because math is more of the rules. Once you know the rules, and then you sort it. Okay, now let's say somebody give you y equal to negative 5, and here look, they give you square root, let's say over x, and they give you 7. So first and foremost, right, I don't need the root. You want to differentiate, you must get rid of the root. You don't need the root. So we know for fact, if somebody gave me square root of x, this same say 1 over 2, 2 over 1. So if I want to change that, that's going to become x, and then you flip the number, it's going to become 1 over 2. So I'm going to remove that square root of x. I'm going to put x 1 over 2, or x a half. So I'm going to remove this. It's going to become x a half. And you need to have a speed, okay, speed of light when you solve the equation, right? You don't have to do too slow. But how the speed come with the practice. So this is going to become x 1 over 2. So the next things, I'm going to take it to the top. So remember, I have not yet differentiated. This is me to write in power and send it to the top. So this is going to become y equal. Now remember, you have a negative 5 over 7. This is going to come into the top. It's going to become x negative, because your reciprocal is going to become negative 1 over 2. Oh, yes. So from here, yes, I can differentiate. Now, see how I'm going to differentiate. So the rules is, it must be in power and send it to the top. It must be power and send it to the top. But there's another question which has a rules, which I'm going to show you more and more, okay? So then, can you differentiate now? Oh, yes. Why? Because number one, our x is in power or is in exponential. And then also is exponential, and also is on top. You must go to the top. Then from there, yes, you can differentiate now. Let's see how we can differentiate now. Let me show you how you can differentiate. So to differentiate here, you say, okay, well, multiply by the number behind. So it's going to become, look, negative times, or you can say negative a half times negative 5 over 7. You multiply the 2. And then you get the answer. And that answer you must write behind. So simply say negative times negative 1 times negative 5. Oh, let's write here on top, sorry. So this is going to become dy equal, let me say it again. So you only start to differentiate when your x is in power and is on top. Okay? So then we're going to say, well, take this. Or you can simply multiply straight away. Look, negative 1 times negative 5 is going to be positive 5. And now 2 times 7 equal to 14. The first number at the top with the top, the bottom with the bottom. Or if you don't know how to do that, you can just simply come here, come to your calculator, drag your calculator right here, and they say, well, I can plug in a calculator. And say, well, take the power, take your power. What is our power? Negative a half. So I'm going to come here and say negative a half. Say negative a half. Negative 1 over 2 over 2. And then you come here, you multiply. And then you multiply. And then come to the power here. Power negative 5. Negative 5 over 7. Negative 5 over 7. And there we go. Oh, this is going to give us 5 over 14, 5 over 14, 5 over 14. So this is going to give us 5 over 14, which is the same thing which I got here, 5 over 14. Okay, let me write a little to the right because I felt like I'm writing 2 to the left. So this is going to become dy over, these are x, I'm going to write dx, equal. Now, when you multiply, it's going to become 5 over 14 like we saw. Write your x, but remember you write at the top. X, take the power minus 1. Negative a half minus 1 is going to give us negative 3 over 2. Negative 3 over 2. So we have already done differentiating, but remember you cannot leave your final answer as a negative power. So we have to do something about it, okay? So we're done differentiating, but then I'm going to say dy over my dx equal, I'll take all this stuff to the bottom here. So I have my 5 over 14, and then this stuff is going to come here at the bottom. It's going to become x, and this is going to become 3 over 2, and I'm done differentiating. There's a lot of other ways you can make it easy, but I can stop there. If I want to simplify further, I can simplify further if I want to. Let me show you how you can do that. But for so long, let's stop there, okay? For so long, I'm going to explain you further how to simplify more. Right there, okay? Let me check more example, which is going to be the last one for this party of the power rule, and then I'm going to show you a little trick, and then we go to the other quotient rule and product rule. Let me check something here, just a minute. Okay, somebody give you, let's say y equal to negative 7 over 2 square root, and then they put here cube and then x. So first and foremost, I don't need the root. So that process before you differentiate, you must get rid of the root. So I'm going to say, well, this is going to become 3 over 1. 3 over 1. Because you need two numbers. And then I'll flip it. So if I flip it, look, it's like x 3 over 1. If I flip, it's going to become x 1 over 3. So I'm going to remove that, and now see this is going to be x 1 over 3. So instead of the root, it must be x 1 over 3. So that's the phase process if you have a root. And then it must go to the top. Remember that. It has to go to the top. It has to go to the top. So I have not yet differentiated, because like I said, for me to differentiate means it must be in power and it must go to the top. Those two little things you need to remember. But if I take this to the top here, look, it's going to be, this is positive, remember, right? So it's going to become negative. So I'm not going to write this x 1 over 3. I'm going to write it to the top. X is going to become negative now. X negative 1 over 3. Only the power become negative. So right here, yes, I can differentiate. Let me write my 2L. Let me write my 2L. Can I differentiate now? Yes. Why? Because this stuff is at the top and is a power. No root right there. Now we go. So this is going to become dy, and these are x's, so it's going to become dx because we differentiate x's. So why I did not write dy dx at the beginning? Because it was not ready for differentiation. It was not ready for differentiation. Now we go ahead. Now, so this is going to become, look, you're going to multiply now negative 7 over 2 multiplied by negative 1 over 3. So I'm going to say negative 1 times negative 7, positive 7 over 3 times 2 is going to give us 6. Write your x, take your power minus 1. Negative 1 over 3 minus 1 is going to become negative 4 over 3. Yeah, negative 4 over 3. Means take this one minus 1. It's like negative 1 over 3 minus 1. So it give us negative 4 over 3. You can plug in a calculator if you want. Let me move my calculator to the right because I need to have some spaces here. And I'm sorry about that. I'm sorry. So then, and then after that, so we're done differentiating, but like I say, you're not going to leave your final answer as a negative power. If it's positive, yes, it's okay. But if it's negative, then let's change it. So then if you have to change, this going to become dy with a dx equal, this going to become negative 7 over 6 as it is. We're going to bring this to the bottom. It's going to become x. This stuff is going to become positive 4 over 3. Okay, so for the basic power rule of differentiation, we're done. Let's go to a little trick a little bit, right? Like I say, math has a rules and you have to follow those rules and regulation, okay? There's no magic here. Rules, know how to apply the rules. Because if I show you all this knowledge, but if it's not applicable, then it's like a useless, okay? Even though it's good to have a knowledge, but if you cannot apply, to me, means you're not ready yet for that, okay? Now, let's give something tricky a little bit. Somebody give you y equal to x, look, minus 4 power, let's say 7. Let's say differentiate. Woo! Now I'm trying to, what is that? Why you give me something with a bracket and like that? Please stop it. Nah, come down. Look how we're going to solve this. It's very easy. So we're going to say, first and foremost, is my equation has a power? Yes. Do we have any square root or root? No. So can you differentiate? Yes. Because the problem every time we say, if we have a root, we don't need the root. Okay? So we're going to say, well, now let's go ahead. So this is going to become dy. Why I say dy? Because we can differentiate. Everything is in power and everything is on top. So we're going to take, look now, you're going to treat this as a one thing. So it's like, okay, let me say it like this. So it's like, okay, let me do it like this. It's like, assume there's nothing here. It's like, you know, when you act like you're blind, like you can't see anything, you just see bracket power 7, something like that. Now let's treat it. How are we going to treat it? We say, okay, let's do like how we did it before. I'm going to take 7 and then put behind here. Right behind the bracket. So it's going to become 7. And then I'm going to write my bracket the way how it is. So it's going to become x cubed minus 4. And take your power minus 1. 7 minus 1 equal to 6. And then when you finish, differentiate what we have here inside the bracket. Now let's differentiate. When you differentiate this, it's going to become 3. Write your x. 3 minus 1 equal to 2. But this is a constant term. There's no x here, so it's going to become just a minus 0. But I don't have to write minus 0. I just write nothing. Because when you differentiate 4 is a constant. There's no x, so it's going to become 0. Okay? And this is going to be a final answer. But remember, these are x's, so you must say over dx. Again. So dy over dx finally, dy over dx equal, write your 7, and then write your x power cube minus 4, 6, and then 3x squared. More example. X squared. More example. More example. More example. More example. Okay? My beautiful familia. Huh? Let's go. The more example, the more you get to understand, right? We don't want to stuck on one example. Okay, don't worry about it. You're going to get to understand. The more example we do, the more you get familiar with the concept, right? Somebody give you, for example, y equal to, okay, let's say 4. Let's say negative 4. X cubed, let's say 4, minus 2x plus 1, and let's say square. Now, before I go for this, okay, let me write this question because I'm going to come and attend right now. I'm going to come and attend this, but I want us to do the example before this one. We want to do the lighter one. Okay, let's do a little example, which is little lighter a little bit before we start with that one, okay? Okay, somebody give, let's say somebody assume you're given, let's say negative 2 over 7 x, let's say this is 4 x power 3 minus 2x plus 7 power 3. So they say differentiate here this power 3. So first and foremost, look at your stuff. Are your stuff in power? Oh yes, everything has a power here. Okay? And then do you have a square root? No. So we don't need square root for the most case. Get rid of the square root. You don't need the square root. So I'm going to say, well, let's just go ahead and say, okay, this is going to become, so since we don't have a root, and then everything is not at the bottom, is at the top. Look, there's a lot of ways you can differentiate, but since you guys are beginner, so I want to show the shortcut ways on solving this. So I'm going to say, well, this is going to become dy over dx equal, I'm going to have to take this power, which is 3 okay, like I say, treat all of this like a one term. Oh, I'm sorry. Treat all of this, treat all of this as you don't see it. So it's like, treat all these brackets as the one thing. So what I'm going to do, I'm going to take 3 multiplied by anything behind. So we're going to have it 3 times negative 2, negative 6, and then over 7 over 7. And then write exactly, like I said, treat as nothing happened there. 4x cubed minus 2x plus 7. And then take your power minus 1. 3 minus 1 equal to 2. Okay? And then after you finish, you come here. Okay, let me just maximize a little bit. I apologize, I'm sorry. A second. And then you say, well, and I'm going to come here. I'll say, well, I have to differentiate what is inside the bracket here. Now we go, let's differentiate now. 3 times 4, 12. Write your x. 3 minus 1, whatever power you have there, minus 1 is going to be 2. But like I told you before, you have minus 2. Oh, it doesn't want to respond here. Oh my God, this is going to be crazy now. Okay, I have to raise here because I apologize. Let me raise and do it again, quick. All in this line because it doesn't want to respond right there. So I'm going to write right to the left. Let me remove my picture. Put your picture there. We're tired of you, Mtwana. Go right there. We don't want to see you. Okay? I'm sorry. Let us now come back, right? You can only see me one eye like Illuminati. Okay? But never mind, eh? So, like, you know, Illuminati stuff, they always hide like one eye. So it's like that right now. Okay? Now we go. So now we're going to say, wow, this is going to become dy over dx equal. So we're going to multiply this power, multiply by n number behind. 3 times negative 2 equal to negative 6 over, write your 7, bracket, write exactly what we have there. That's why I have kind of highlighted 2x plus 7. Go to your power, minus 1. 3 minus 1 equal to 2. And then the next thing now, differentiate what we have here inside. Now, 3 times, like whatever we have inside the bracket, now let's differentiate that. Now, 3 times 2, 12. Write your x. 3 minus 1 equal to 2. Minus. This is going to become 2. But when you differentiate x, like I told you, it's going to become 1. We did that. We said it many times because it does not have a power. So when you differentiate x, it's going to become 1. So it's going to become 2 times 1. 2 times 1 is just a 2. So this is 7. It does not have x. So we assume it's a constant. When you differentiate 7, it's going to become 0. So it's like a plus 0. Plus 0 here. Negative 2 plus 0. But I don't need to say plus 0 because, you know, I don't need, like, it's just a 0. So I don't need. So I'm going to close my bracket and I'm done differentiating. And then finally, I'm going to say now, this is going to be my final answer. I'll have to do more example for this. I definitely have to do more example. But a more example is going to be that question which I write down on the left. Okay. So now let's come here. I'm gonna come back, right? Never mind, like you don't see me fully. I'm gonna bring back my face soon. Just say, where you at now? We can't see you. What are you doing now? Why are you doing the things? You know. Very soon you're gonna see me. So check this out. So then I'm gonna say, well, look, they say differentiate this. So first and foremost, we say we don't need. It should not be at the bottom. It should not be at the bottom. So do you have a root? You know, root like stuff like that. Do we have that? No, we don't have. We don't have that. But also, we don't need it to be at the bottom because if it's at the bottom, then it's a problem. So what I'm going to do, I'm going to have to reciprocate. Excuse me, I have to bring here to the top. So then this term, when you bring to the top, remember you bring everything. So all this stuff is going to come here. So then our term is going to become what? Or expression is going to become y equal negative 4, just a negative 4 bracket. Break up. We're going to bring to the top. It's going to become 4x power cube and then minus 2x and then plus 3. But this stuff is not going to be positive 2 no more. It's going to become negative 2. That's going to be the first step. So then after, then we can differentiate. Now we can differentiate. Then we can differentiate. Now let's differentiate. So the differentiate here is easy. So this is going to become, look, this is y. When you differentiate y, it's going to become what? dy. But these are x. You're going to say over dx. And then equal, now, negative 2 times 4. It's going to become negative 8. And then write what you have here exactly with a bracket, which is going to be 4x cubed minus 2x plus 3 power. This negative 2, or whichever power is there, you must minus 1. Negative 2 minus 1 is going to become negative 3. And then after that, now differentiate what you have here inside the bracket. So now let's go. 3 times 4, 12x. Take this power minus 1. 3 minus 1 equal to 2. Minus. This is going to become 2. But when you differentiate, x is going to give us 1 because x is constant. When you differentiate 3 has no x, so it's going to become 0. So we're going to say plus 0. So I don't have to say plus 0 because I don't have anything right there. So we just say 0. 2 times 1 is just a 2. So this is already differentiated. But hey, look. Like we say, we don't need our final answer with a negative power. But remember, this is like this. So I'm going to take all of these with the bracket to the bottom. So this is going to become dy over dx equal to we have a negative 8, but all this stuff is going to go to the bottom because it has a negative power. Remember, you treat it as a one thing. When you have a bracket, it's like, where do you stay? You say, I stay in that house. Okay, so if something happened at your house or your friends, oh, that house right there, they're not going to say only that person. If you hang around with the people do some wrong thing, they're going to say, she also do that. He also do that. You see what I'm saying? But if you do the right thing, look, man, if you see me move like a president, okay, let me move my picture right here, man, because I'm about to I need to get serious right now. To move close to you. Okay. Move a little bit. This one so you can see me a little. Look, if you move like a president, like me, you know, I do my movement like a president. I don't just hang around. Every time I do my works at home or I got some meeting, I move like a president. Okay? So if you see me hang around with the president, okay, or somebody with a higher rank, then people go say, oh, you know, Mtwana, he's with president of this country. He's the president of Russia, Vladimir Putin, or he's the president of wherever. Okay? So if something happened to whoever you hang around with, then people gonna assume, oh, he's people. He's people. Okay? So same here. See, I went out of the topic right now and I apologize. So same here. All these things treat as a one because it's in the same bracket. But remember, I'm going to take it to the bottom because even though I'm done differentiating, I'll take it to the bottom. Why? Because there's a negative power. We don't need a final answer with a negative power. So I'm going to take all of this bracket, 4x cubed minus 2x plus 3. This power is going to become 3. Positive, not negative no more. It's like a positive. And then this stuff is on top, remember, right? So I'm going to write here. 12x squared minus 2. And then we're done with it. Okay? More example. More example. I can do one more. And then we know we're going to be done with this. And then I can show you something else. I can show you something because we need to do with 2 more. 2 more rules and then we'll be done with the rules. Okay? Because for you to solve a question, because I got some question here. But for you to solve all this question, let me show you. For you to solve all this question here, you have to know the rules. See, we got the question here. We need to solve all this question here. All this question here. We need to solve all this question here. But then you have to know the rules. Because you won't be able to solve any question if you don't know the rules. It's like, how are you going to do the job or you're going to do the work if you don't know the rules and regulations? That's why everywhere you go, there's a rules and regulation. Means you have to follow those rules. If you don't, then you're going to be in trouble. You're going to get fired. You have a problem with the people, right? Because you're going to do things in your own way. You don't feel, say, why you do like that? See, you have to follow the guidelines. So math is the same thing. You have to follow the rules, the regulation, and guidelines, okay, which is going to guide you to solve the equation. Okay? Now, what I want to show you right now. Let me drink your water a little bit, and I appreciate for your patience. More example with the power rule. Somebody give you, this is going to be the last example. This is somebody give you 4. Let's say 2. Let's say differentiate. So first and foremost, you don't need this root. This root I don't need. It has to go. But we know if you have to remove this root, it's going to be 1 over 2 because this is like a 2 over 1. If you know there's nothing written right there, but it's like 2 over 1. So then if I remove this root, it's going to become x cubed minus 8x squared plus 5, and it's going to become 1 over 2. That's the first step, okay? So I'm going to replace that with this. So the first thing, I don't need the root. Root must be power. So then I'm going to say this is going to become x cubed minus 8x squared plus 5, and this is going to become 1 over 2. The next step, that expression mathematically must go to the top. So I'm going to reciprocate this must go to the top. It's just simple. When you go to the top, remember this is positive as it is. So when you go to the top, it must be negative. So it must be not root, and it must be in power. So if I take to the top, and then I'm not going to have to write to the bottom. It's going to be bracket x cubed minus 8x plus 5 is going to be negative what? Negative a half. And then I don't have to write this. So those are rules I'm following, okay? I don't just do for my head like, okay, I want to do like this. Let me just do like this. No, I follow the rules. Rules, we don't need a power. Zandi, so she's, hey, I'm Zandi, so I'm right here. Hey, I'm right here. Zandi, so I see you right there. I see you. Nikelo Zandi, so I see you right there. Kamogelo and everybody. Lina Mahla, Innocent Mamela, Portia's Bongil. I see everybody here, my beautiful family. Listen, click the like button, show your boy some loves, okay? 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 Don't be a hater, okay? Don't be like my beautiful family who I had yesterday. One of them, he was a hater. He didn't wanna like the videos like, yo, come on. Don't be like that boy. Now let's go ahead and do it. So we're gonna say we have changed the whole question like that. So now we can differentiate because everything in power and we don't have no root. So I'm gonna say this y is gonna become dy. Okay, it's gonna become dy. It's gonna become dy. And then these are x is gonna become dx. Now let's go ahead, multiply a half times 4. It's like a 4 times negative a half. It's not even negative a half. After negative 4 times negative a half equal to negative 2. So if I multiply a half negative times 4 is going to become negative 2. Write your bracket, treat as a one thing. So if you treat it, let me start at the left a little bit. Start it way to the right. I have to start it to the left. To the left, to the left. This is going to become dy over dx equal. Now, negative a half times 4 is going to be negative 2. Put your bracket right the way how it is. X cubed minus 8x plus 5. Take negative a half minus 1. Negative a half minus 1 is going to give us negative 3 over 2. Whatever you have here, always minus 1. And then after, differentiate what you have here. So then, how are we going to differentiate that? Look, 3 is going to come here. Write your x. Take your power minus 1. 3 minus 1 equal to 2. Minus, minus. This 8 is going to be 80, but when you differentiate x, you get 1. So 8 times 1 is just 8. Okay, and then when you differentiate 5, it does not have no x. Means it's going to become just a plus 0. So I don't have to say plus 0 because I don't need the 0. So just say 8. So for that being said, we close the bracket. So then we're done with our solving. But hey, look, we can never leave our final answers in negative power. So it means this is going to go to the bottom here, at the bottom. So then I'm going to say dy over dx equal negative 2, negative 2. And then I'm going to write a line. All this is going to go to the bottom. Why? Because there's a negative power. Only if there's a negative power. So this is going to come here, say x cubed minus 8x plus 5. And then this is going to become positive. It's going to become 3 over 2. And then this is on top. So I'm going to say 3x squared minus 8. And that is said we're done with that question. Let's go ahead and do the second question. Okay, I'll check something here. Check your question quick. Sorry about that. Okay, very soon. Okay, cool. So now let's go to the next question. Sorry about that. I was just checking the question. So now let's go to the question now, to the actual question. Let me show you some here, something very, very important now. Hey, I'm Zandi. So I see you, Zandi. So right there. Okay, let's go, my beautiful family. Look. Look, right? So apart from those rules, so you need to look at your expression, right? Apart from those rules, let me tell you something. Sometime you're gonna have something like this. Look, because what we saw it was like this. Look, let me show you what we have been doing recently. If you have expression like this, we did already. Like something similar like this, not like exactly. Then we know we're gonna have to remove this root, and then we're gonna write the power, and then we're gonna take to the top. That one's clear. Now, and then other situation, is when we had something like, let's say y equal to, let's say 4x cubed minus, it's not like exactly the same, but a rough example. Also, we have seen this. But now sometimes they're not going to give like that. They're going to give, you see here, most of this stuff we have seen is only one function. You see, these are only one function. Like if somebody give you, let's say 4x4, can you see it's only one function, only one function. So we're going to come to the situation where we have a two function. We want to see how we're going to do that. Because if you can look careful, all the example we'll be doing, it's just only one function. Like y, let's say -3. What is a function? This is a function here. What about this? This is only one function, one function, one function. Okay? Let's take example where we have a two function. Let's take example where we have two function. Then we can do only 3 examples, and then we're going to stop there. Okay? We don't want to make a very long video. Okay? Because I don't want you to start to get confused. Just say 2 examples. So now, let's say somebody give you y equal to x power 3, and then they give you another example which say 2x power 4 minus 3x power 7. So don't you see we have a two function here, the first function, second function. So you have a two function, but between this function we have a multiplication, or we say the product of the two functions. So if you, in that case, we have a rule which is called product rule of differentiation. The product rule of the differentiation. So you're going to have to use the product rules of differentiation. If you have, for example, let me take another example. If you have, let's say, y equal to, let's say, somebody give you x squared minus 4x over, let's say, sine of x. Can't you see we have a two function? The first function over another function. So this is a quotient rule, because there's a division. Quotient means division in differentiation, or it's just an English word, means division. So you see we have a two function, but there's a division, which is not the same as how we had before. Before we had something like, let's say, y equal to 1. So it's only one function. But now we're gonna be dealing with it. We're gonna be dealing with it one function multiplied by another function. One function divided by another function. So I think let's move this to the next class so that I'm not gonna confuse you with a lot of information. Okay. So next time we're gonna learn the product rule. When you have a two function, and then you find the product of them, or you find the quotient of them, means division of them. For that being said, my beautiful familia, thanks a lot for coming through. Do not forget to click the like button. We stop there. But before we stop, anything that you want me to repeat, please let me know. I'm going to repeat right now. Or if you want me to do over, let me know. For what we have done. But if you understood, just leave a comment that say, Twana, hey, I understood most of the stuff. If you understood 70%, 80%, or 90%, or 100% of what we did, then you should be fine. Don't worry about it. I'm going to do this stuff over and over. You're going to get used to it. It's like learning how to drive a car, or to kick a ball, or for a child when they walk. They're walking for, they start crawling, and they end up walking and run. Okay? So same with math. It's just a face they might get you confused a little bit. So, oh, I kind of get confused, but I understood. When you do that again, next time, you get used to that. Okay? But if you understood, please just click that like button right under the video where they say differentiation, derivative, please help how to solve. There's a like button. Click that. And then I'm just waiting for your comments here before I say good night. Because I don't want to make a very long video, because one thing I've learned, sometimes we can spend 3 hours and learn few things. But rather we can spend 1 hour and learn a lot. That's what I've learned. It's just my approach, which I'm checking from now on. I do many example, lot of example, and they will spend short time and you learn more. So even when you practice or when you learn, make sure you spend less time and learn more. You see what I'm saying? Do that all the time, because it's gonna happen. You learn a lot, and then you're gonna have a speed. So even when you practice, do not learn like, okay, it's 2, take it to the bottom. Now you gotta be aggressive a little bit, right? Use my approach. Do FaceTime when you know how to do it. Force yourself. You see, so just like how you learn to drive a car or you learn how to kick a ball, okay, you must practice. You see, all these players, like all these players, your favorite player or favorite singer or gospel singer or rap singer or somebody who do like anything, they do practice. Even working place, for you to do the right thing, you must practice. Okay, thank you. Portia, she write, they say, thank you, Mtwana, understood. Lina Matle, Mabusila, say, I understood, thank you, Giabonga, thank you. Okay, Kialeboga. All right, so if you understood, please let me know. But like I said, don't worry about it. We're going to do this stuff every day, every time. So you get used to that. But like I said, even when you practice, always practice with the speed. Okay, trying to imitate what I do. Try to do, just get my hype up, like, okay, now I'm gonna differentiate. Let me do like I'm trying to right now. This X3. People say, why you start like say, listen, don't worry about it. I wanna do like I'm trying to, okay? And then you're gonna get used to it. Be hype up. Start to love what you do. It's gonna be very easy, I promise you. So for that being said, look, do not forget to click the like button from Twana Wabantu. Okay? And here, look, we're gonna have another one day after tomorrow. Or no, I'm gonna reach you guys in your inbox, and then we're gonna arrange for the next one. Okay, for that being said, my beautiful family, let me get my mic closed. Okay, thanks a lot for coming through. And hey, we got another program also for giving back to the community. As you know, do not forget where you come from, right? Always have some impact, even if it's not for your community. Try to go other places. Also, do. There's a lot of things you can do for someone to make to bring a smile to people. I mean, just make the people happy, man. You know, compliment somebody, make other people happy. Okay, if there's anything you can do for your community too, do it. Okay, when you got time, you go to a rural place. Now, look, I'm not like a preacher or pastor or some or religious or whatever. I'm just saying, you know, get some stuff, go there, do some little changes. Okay, help a little young girls right there in your community, anywhere. You go to a Kasi or rural sometime and travel, do a little change. You don't have to have a lot for you to do a little changes. Okay? Teach little girl how to add and subtract. Teach her how to dance. Teach her how to play netball. Teach her how to jump. You see what I'm saying? So just a little change. Tell her stories. Okay? So don't forget to do, you know, always give back. It's not necessarily must be money. It could be knowledge. It could be hope. It could be inspirational. You know, just give people hope. You know, give people hope. You know, share what you little you have. Like, look, I got something little, but look, come here, get some piece of inyama here. You know, you see what I'm saying? Hey, look, thanks a lot for your time, my beautiful family. Thanks so much for coming through. And like I say, right, we're gonna meet up very very soon for the next one, right? Do not always practice. As far as no, for right now, don't worry about if you won't be able to solve a lot of questions. For now, don't worry about it. Don't do anything. You know, you can just practice what I've shown you. Rewatch the video, redo what I showed you with the high speed. Watch, do, okay? Just to get used to that. And then the next one now, you're going to be able to solve a lot of questions, okay? Because next one, we're going to get busy. We're going to get busy. Thanks a lot for coming through. That being said, your one and only loved family, okay? So, I'm going to see you very soon. For the new ones, just in case, be free, reach me inbox, okay? So you get to learn. Thanks a lot for that being said. And if you want to see what we do for the community, just click the link below. Under this video, we have a link where you can see what we do, changes for the community, man, help people with the mental illness, equip, especially homeless people or children who have been dropping out of the school, or some of them, the parents are under influence of the drugs or alcohol. So we have to reinstall those kids in school so they can have the right of education, or sometimes equip them the skills so they can change their lives and the loved ones, because you never know who might become, you know. So yeah, thanks a lot for your time. Peace, and I must see you very soon. You know me, I never stop. When I start to talk here, it's gonna be non-stop. So let's stop right now. Let's stop right now, my beautiful family. Do not forget to share this. Oh, no, just click the like button. And for that, we say good night. Good night. Good night. Goodbye. Goms. Bye-bye. For that, we say goodbye.